Well, good morning, everybody. Good evening, wherever you are in the world. Hope you had a nice weekend. My name's Daniel Hourigan. I'm the head of effects at CGS Spectrum, and welcome to another edition of CGS Live Houdini, VFX in Houdini. Hi, how's everyone going? Hey, Alan, how's it going? Welcome, nice to see you again. I don't know what I'm gonna do today. I don't know. I'm kind of a bit bored of the thing I was working on last week, so I thought I might start something else. And someone shared something on our internal chat in the school. We have an internal Slack community, which is great. And John shared a rookies challenge, which I thought would be a cool thing to share with everybody, because there's always, it's always a bit of fun to do a rookies challenge. These are for students and self-taught artists, aspiring artists. They're not for me to enter, but I can still have fun messing with it. And Stranger Things is something that I really enjoy. Hey Ivan, how's it going? So, Ivan, you might be interested in this, seeing as you followed along my other Stranger Things streams. So go and check those out if you haven't seen them. I did a couple of just weird blobby simulations in Houdini. So hey, Moneyval, how's it going? I am talking Houdini, all things VFX and Houdini, and I am just having a look at this. I should share my screen, that might help. So the rookies have opened. It's not open yet, it's on the 1st of November. This Netflix and Stranger Things kind of Netflix and skill, I guess that's a pun. Stranger Things competition. So it's got a few categories, and you can see there's an animate category, a render category, and a design category. And I just thought, well, it's a good, I really enjoy Stranger Things, so I might have a crack at doing something just to get you guys started. But if anyone's interested, you could have a look at this. It's at therookies.co, and you can find their contests page. They often have, lots of different ones. This one's going at the moment, I think, the Night Spider Animation Challenge. Yeah, let me try and put it in the chat. There we go. See if that works. So yeah, I'm gonna just have some fun today doing, some Stranger Things inspired stuff, messing around. Hey, Mimo El Mimo. I can't read what you wrote there. Oh, I think I understand though. I think you were saying I appreciate the classes. Maybe my what was that, Spanish? Maybe my Spanish is not great. But thank you if that's what you meant. I was checking out Important Looking Pirates intern challenge. Oh, okay, cool. Yeah, look, it's good to do this stuff. It's good to test your skills and to learn new techniques. And a competition or a contest just gives you that kind of drive to. And something, a brief was always sometimes difficult when you're learning. So I'm just gonna kind of start messing around. I started loading in some assets, some trees. What I was thinking of doing was sort of having a look at the sort of what do they call it, the upside down, that sort of world where the creatures come from. And oh, that's interesting. There's a TV here. I was just looking at getting a TV model. I was sort of browsing model sites. There's this one site called Polyhaven. Here you go. You can see there's a TV. So the other thing about Stranger Things, and probably why I like it, is because it's 80s. So any sort of 80s models might work really well. So I've just been looking on Polyhaven here, which has a ton of free stuff, and they have a whole bunch of kind of well, not a whole bunch, they've got a few 80s kind of things that you could potentially use. I like this cassette recorder. I think I already have this downloaded, but I grabbed the Walkman and the TV to play around with as well. I don't think there's tons of that sort of stuff on here, but let's have a look at electronics. Yeah, not loads. Yeah, you can see they only have 105 models total, but there's bound to be some, you know, useful stuff on here. And there's other websites like Megascans and, you know, places like that that you could try out as well if you wanted to get some models to play around with. But yeah, let's have a little play. So I've just loaded in some trees because I thought I might build a sort of foresty type environment. And I'm just gonna go and, you know, sort of move these around. These are Megascans trees. You could make your own as well if you wanted to show off your modeling, you know, procedural modeling skills in Houdini. You could try just making your own sort of assets as well. Hey Sebastian, thank you. What do you recommend we start with in Houdini? Any good tutorial recommendations? Oh, you're in the 3D modeling course. Cool. Look, I think you know, starting off, it's best to start simple. Don't dive straight into you know, complex simulations. I mean, you can, and it's fun to do that, but it's also, you know, you got to be mindful of just when you do that, you know, there might just be like this massive kind of I guess whole bunch of information that you're not really understanding, and it's fun to mess with those tools and just treat them as kind of experiments and stuff like that, but it's really important to understand, you know, the fundamentals of how Houdini works, and yeah, just kind of try to understand attributes and all that kind of stuff. Moneyval, floating leaves, objects, etc. Found setting up rotations, floating object difficult. Oh, okay, interesting. We could take a look at that, Moneyval. Yeah, look, the SideFX website is a good place to start. They do have a whole bunch of very basic introduction tutorials. I mean, obviously, we have our Introduction to Houdini course at CG Spectrum, but you're already studying another course, I can see. So if you wanted to, you know, just have a look at some other stuff, by all means, you know, check out the SideFX website and look at their intro sort of videos that they have there, and just sort of see, you know, if you can do some of the more basic ones, and really try to understand the fundamental stuff before you know, go crazy with the simulation. I know there's a temptation to, you know, just want to do all the really fun stuff all the time, but it can, you know, it can bite you, and I speak from experience because that's what I did. You know, I wanted to just do simulations, and it took me years to really kind of work out how Houdini really worked and sort of, you know, really understand it. And I could have gotten there sooner if I had focused on fundamentals first and not dived straight into simulations. I just realized that all the scale of these is just way too small. So I mean, way too large. If you have a look, you can see I'm looking at like 250 meters here. So I'm just going to scale everything down. Because this grid is 100 by 100, which is still pretty big. And that's one thing you need to be aware of when you're just when you're working with assets that you bring in from various places. They can often be really big, so you kind of want to make sure that you scale them down. It's much easier to work closer to the origin than really far away. Just makes everything a little bit harder. All right, so I don't know, you know, what I'm aiming for here, but I'm just kind of messing around with these different assets. And this is, you know, this is how I work with them. I kind of just scale things up and down. It looks like that's actually the same. Let me make a camera here. New camera. Looks like this asset, and yeah, so they're the same asset. Let's have a look at this one. This one looks better. Yeah, feel free to reach out on Slack, Sebastian, seeing as you're in CGS. Reach out, join the general channel as well, the general Houdini channel on our CGS Slack will, you know, give you tons of, you know, kind of help if you need it. There's lots of people on there, there's lots of mentors on there, so, you know, if you ever need anything, you can kind of ask on there. And someone will answer your question, whether it's a alumni student or whether it's a mentor. You know, you'll be able to get your answers there pretty quickly. Forums are really good as well, you know, the Side Effects forum and Oddforce forums. Oddforce I find a little bit better than Side Effects for answers, but yeah, they're both good, you know, so utilize the forums as well. Often if you've had a problem in Houdini, you know, 100 other people or 1,000 other people have as well, especially the beginner kind of issues that are all very common. So always check forums, you know, I always Google for the answers, and, you know, usually a forum hit comes up for somebody having had the same problem. So you can see I'm not scattering here or anything. I'm not just doing like a brute force kind of layout. I'm intentionally choosing where to position these trees at this stage. You could also do a scatter if you wanted to, but I like to, you know, especially with the larger trees, I think it's good to sort of lay them out by hand to get, you know, to get that very designed look. We're going for, you know, something that's potentially going to be very stylized, or, you know, just very intentional rather than a very haphazard kind of thing. So I just want to make sure that I get things in the right spot. You know, I can use the branches to frame the scene. Whereas if I just did a scatter and scattered trees everywhere, it might be a little more difficult to, you know, really position things. But you can do combinations of stuff. So what I'm imagining in the back of my mind while I'm laying these out is that I'm going to do some kind of like spider web or growth or something. You know, that's something that I sort of remember from Stranger Things, is that the kind of weird slimy growth sort of stuff that's going on in those, you know, in that underworld, whatever it's called, upside down. This tree, this branch, I think probably doesn't work as a standing up tree, so I might just rotate it. So I'm kind of thinking about, you know, when I do that procedural effect of stuff growing over all this, how's that going to look? I think, you know, I can imagine it looking quite cool, climbing up this big tree stump, and maybe I need another one of those somewhere. You have to be careful though when you're using the same asset over and over again. You know, you don't want to have too much double up, otherwise it just looks repeated. But if you rotate it around, say, and you know, potentially change the scale a little bit, then they start to look a little bit different. Yeah, you just want to be careful with that kind of reusing things over and over again. Alright, so it's pretty sparse. There's not a lot going on here, but hopefully now we could even try and scatter some additional trees. Or I have this as well, which is a collection of twigs. This is also from Megascans. You'll see that there are, if I have a look here, 214 packed alembics in here. So there's a whole bunch of twigs and they're all just sitting over each other at origin. If I unpack them, you will see that they have a class attribute, which is defining each twig as a separate object. So if I was to do a for each named primitive, that class attribute is primitive, I think. Yeah, it's primitive. So for each named primitive, by default that is set to name. But if I change that to class, inside this for each loop, I should be able to see individual twigs. They're very low res. Let me just check, make sure I got the right LOD. Because there's level of detail with some of these assets. So LOD 0, LOD 1, yeah, it is. What I might do is put a UV quick shade so they look a bit more like what they will end up looking like if I render them. So you can see they have UVs. Let's go and see if we can put the, there we go, put the texture on. There we go, it looks a bit better. And then reset. Hey, there we go, look at that. So inside of here I can view each individual stick if I wanted to. If I turn on single pass, I can actually loop through those individually and just see what they look like. That's quite handy. But what I'm going to do is I'm going to take my ground plane, scatter points on it, and then I'm going to do, what am I going to do? I'm going to do a for each point on this scatter. And then inside here is a single point now. Instead of all these points, inside the for each point, I get each point individually, just like I had each stick individually on the other side. So over here I get a point. And then if I do copy to points on here, and plug in, let's see, what do I want to do? How do I want to do this? I'm going to put a blast down, and I'm just going to blast based on class. So I'm going to say at class equals, I'm just going to pick one to start with. I'm just going to say class 1, delete non-selected. Then you can see I just get a single stick there. Copy that on. Got those around the wrong way. There we go. So there's my point. If I come out here now, I should get, there we go. It's the same stick every time because I've only isolated one at the moment and I haven't made it update dynamically. But what I want to do is kind of vary which stick I get over all of these, and I also want to vary the scale of it, the rotation of it. So I'm going to put an attribute wrangle here, and I'm going to say at p scale equals rand at pt num. And you'll see what that gives me. It gives me a random scale for each stick. It's giving me a random scale between 0 and 1, so some of them potentially are getting a 0 scale, which wouldn't be ideal. So I'm going to fit this. So fit 0, 1, because the random is between 0 and 1 already, I can say fit 0, 1, which eliminates the need to put an old min and old max in a fit. So fit 0, 1 just assumes that the old min and old max are 0 to 1. And then I can just say maybe 0.25 to 1.5. There we go. Now, another way of doing this is to use an attribute randomize. And I'm going to use this to do something else. So I could do p-scale with this, but I'm going to use this to vary rotation. And that attribute is called rot. And it's a 4-dimensional vector. So it's dimensions 4. And then it will give you, the attribute randomize will give you a random value on each axis. So you can see X, Y, and Z, and then the 4th dimension is rotation around the axis that's defined in the first 3. So this is X, Y, Z, and then rotation. Let's have a look. We should get sticks kind of rotated everywhere. There we go. It's not really what I want. So what I'm going to do is just mess with the random value of the axes. So I'm going to zero out X and Z. Okay, now we're just getting random rotations on Y. So you can see now I'm just getting sticks kind of lying flat on the ground without any sort of tilt on X or Z. So that's another way of doing it, attribute randomize. Now the scale looks too big to me because I did not scale this down. Let's put a transform on here. And so every time it does that, it cooks the for each loop. Which at the moment, there's actually no need to do the for each loop at the moment because I'm not really utilizing the power of it. But there we go, you can see without it, it's very quick. So I've scaled that down to 0.1. Maybe I can mess with my p-scale a bit now. Let's go 0.5. 2.5. Let's check through my camera. There we go. Now the scatter has, by default, relax. I'm going to turn that off because you can see it gives like a very even pattern. If I turn it off, then you kind of get a more random distribution of points. Some of them may be touching each other, which isn't ideal when you're copying. You can see we've got overlapping here. It probably doesn't matter in the scheme of things, but if you wanted to avoid that, what you could try is putting a fuse down. And you can see that I've got this cluster of points which is sort of reasonably close together, or this one here. As I up my snap distance, you'll see those points fuse together, like these two here fuse together. So this is a kind of easy way of just fusing those nearby points together so that you get less sticks that are really close together. And then you can see there's much less overlapping going on. Now there are more mathematical ways of doing that to kind of calculate the scale for each stick. But yeah, that's a nice kind of easy one. You can always up the scatter amount as well. And you'll see, with the fuse, I get a ton of sticks and they're all overlapping, but when I put the fuse on, it sort of spaces out things a little bit. And, it actually ends up looking a little more relaxed, like the relaxed version of the scatter. So I've done a pretty large snap distance, so you can just play with that. There are lots of kind of ways of doing that. You can see I've got a bit more overlapping now. Alright. And attribute randomize, we could always just add a tiny amount into the X and Z. So I'm going to do negative on the min and positive on the max, and you can see now I get a little bit of rotation, but not crazy amounts. So it's probably too many sticks, but So let's now try and vary the stick for each point. So what I'm going to do is, let's see, what do we want to do? With the copy to points, you have the ability to add a variant attribute. So I'm going to, what am I going to do here? I'm going to do a variant. So I need to create a variant attribute. I could do it with the attribute randomize again, probably, but I'm going to say at variant equals rand at ptnum. Again, same as what I did for p-scale. What that's going to give me is just a random variant value between 0 and 1. But I'm going to then fit 0, 1. And I know that I have over here 214 packed alembics. So what I could do is say at variant equals fit 0, 1 rand ptnum between 0 and 214. And if we have a look at what we have now, let's make it an integer. There we go. 0 and 213. So what you actually need to do to get the 214th one is just go up 1, because the rounding from the integer, it rounds it down. So if I do 215, now it becomes 214. So we need to give this same value over here. And what will happen is when it comes in, when the point comes in, we should get a variant value, 89, and then it will find a corresponding variant value over here, 89, and match those two up. That's the theory. So let's create the same value over here. I'm going to attribute promote the class attribute from primitive to point. And that just moves it from being a primitive to being a point. We should see their class. Although we're only seeing class 1. Oh wait, turn off my blast. There we go, 0 to, actually there's only 213, so I should leave that at 214. Okay, so now we've got that as that, and now what we can do is create a variant. So we're just going to do this. I at variant equals at class. Basically just copying that class value into the variant attribute value. And now, so we've got all our sticks here in a big pile. We've got piece attribute variant. There we go, got a different stick. Let's have a look. It's going to go through, cook all those points. And look at that. We got a different stick on every point. So it just goes through and it'll just swap out whatever with this copy of points. It's clever enough to go, cool, I got a point which has a class attribute on it or a variant attribute. Let's create a marker so we can see it. There it is. So it's got variant 194. It goes into this side and looks for the same variant value of 194, and it'll copy that piece on. There you go. You can see that one has the variant 194 as well, and it's just going to loop through all those points, create that match, and you end up with just random objects. And if you wanted to change it, you could create a seed. So by adding a number to the random, the value that you're running the random over, that will essentially change the seed of the random, and you'll see it'll force the for each to recalculate, and we'll get a different amount of sticks or a different distribution of those variants, because it's changing it. The random value is changing, so it's changing which points have the variant value. So you could go through and, you know, change that to suit what you wanted. So let's merge all that together and see, you know, we can see those kind of sticks scattered there. It's all a bit kind of uniform, but we could also do something like this where we take our scatter, which is kind of everywhere, and maybe we'll add, whoops, not that, attribute VOP, turbulent noise. I'm just going to plug that into color. And then I'm going to blast at cd.x, so based on the color value of just the red channel, greater than 0.1 points. You can see those get deleted, so I'm just going to crank up this so we can see it a little clearer. Maybe make my background dark. So my noise, probably my frequency is a bit large. There we go. Or a bit small, I mean. I can even play with the contrast of this by putting a fit down and crushing those values. There you go. So what I should be able to do through this, now I've got my blast, is I can either delete the white, so that's what I'm doing here, deleting anything that's sort of larger than the black value, or I could do less than as well, and that would delete the black. So I just keep those little patches. Then if I use my fuse to fuse everything together and run that through my for each, I'll get just these little patches of sticks instead of sticks uniformly everywhere, and that might look a bit more interesting. And I could always scatter other things around in gaps, or maybe not. I don't know. It's always good to create variation and variance when you're doing this stuff. The more you do, the more realistic things can look. I'm just going to move this tree up. Which one is it? That one at the back there. Okay. Alright. So, that's okay. This needs loads more work to get it, to where I want. But that's kind of, an interesting start. There's a lot of depth in that background which needs to be kind of filled in, but maybe that could be fogged out. Maybe you just create rows of trees going back, or a scattering of trees at the back there might be interesting, just to create that kind of depth to it, and then do a fog. But what I want to try now is, I'll ignore my sticks for a moment, and then let's take everything that we merged together here. Let's just check and see what it is. Open polygons, that's good. What am I going to do? I might remesh everything to create consistent topology. Let's see if that works. There we go. So what the remesh did is just went and turned everything to tries, and you can see that everything's the same now. So the ground and the trees, everything has this consistent topology. One thing that I could do instead of that is I might need to poly extrude my grid here to give it thickness. But one thing I could try is turning this into a volume first. So I might do that negative. I'll put back. Another way to just extrude a plane down is to use extrude volume, which can be good as well. It's just easy. So I'm just going to do this over here, separate. Whoops. Trees and the ground. So merge those together like that, and then do a VDB from polygons. Turn everything into a volume. And we can see these ones didn't work so well, so probably those trees need to be filled. So I'm just going to stick a polyfill down here, because the VDB will create volume from perfectly what we call watertight models, perfectly enclosed, perfectly closed surfaces. If there's open faces, it doesn't work so well. So put a polyfill there, and that will cap any open faces, or it should. Look, it doesn't look like it actually did on those ones, but that did seem to fix the issue. Probably because these are going through this box, the VDB just treats it all as one kind of object, so yeah, it seems like it's okay. I've got a lot of this grid here outside my camera, so you know, there's a bit of wasted space there. I might just gonna chuck a null here and look at this grid. I'm just going to slice off some of this, just make it slightly more efficient. There we go. And now what I'm going to do is put a convert down. So if I convert VDB now to polygons, I get a similar thing, except what the VDB is giving me, instead of the remesh, the remesh still keeps the tree, even though it's inside the, you know, even though it's going through the grid, it sort of keeps them separate still. But turning it all into a volume first and then converting it to polygons, you can see how the sticks have kind of blended into the ground and the tree is blended into the ground. So these are now all one mesh. If I was to double click on a polygon, it selects everything. Whereas if I was to do that on the remesh and click on the ground, you can see it's still just the ground separate. The trees are separate. So what I could use this for, I actually might still do a remesh now, but now the whole ground is just one homogeneous mesh. I'm going to, let's see, I'll remesh it, wait for it to do its thing. It's creating a lot of mesh. It's probably quite high resolution now. So it's going to take a little while. Coffee break. And it's done. You know, it's probably a little bit too much. Too many subdivisions. I don't know. I could probably take the target size up. But let's see what it looks like. What I'm going to do is use a really cool node called Find Shortest Path. And what this does is it takes defined start points and defined end points and finds the shortest path along the mesh to get to them. So to show you an example, if I pick a start point, hit enter, and then pick an end point, it will give me a line along that. And by having a nice detailed mesh, it gives you a nice detailed line. If the mesh was low resolution, or if it was polygons, it would be very straight and angular. But by doing the remesh, which has nice kind of connecting triangles, it gives you this nice wiggly line. But what is really cool is when you do multiple start and end points. So I'm going to just add more points to this end points from this single start point. And I'm going to choose from any start to any, from each start to each end, or from any start to each end. There we go. So you can see it gives me this cool kind of veiny look. It creeps out over the surface. And I've only picked at the moment just the ground. So let's pick bits in the trees, you know, all around the place. And you get this cool kind of ivy growth, essentially. Like it just kind of looks like it grows along the surface. So that when I then merge that with my stuff again, you know, I get this kind of stuff creeping out. Maybe I'll do a poly wire to give it thickness. You can see how it's crept along the surface of those. Let's give it a color so you can see it. So it looks particularly cool when it, you know, has gone up the tree here. It's a bit weird, you know, single starting point creeping out like that, but you can have multiple start points. So, you know, we could pick multiple start points around there, and then you can see that they sort of, you know, I've got it from any start to each end, or each start to each end will give me this kind of massive crisscross, and that's quite interesting. Still a little bit kind of angular, but quite interesting on the tree. What I really like to do after I get this as well is to maybe do a smooth, and you can, you know, you can smooth this stuff out. Turn off group boundary. You can get some interesting kind of smooth effects. Even use an attribute blur, which is set to P by default. Also by default, it's set to pin border points. If you turn that off, also turn off connectivity and do by proximity, you can get this really nice cellular pattern, which we've seen. If you know, you're a fan of the streams and you've been with me for a while, you would have seen me do this stuff on the foam for the wave, where it creates that really nice cellular pattern, and that can be really cool. You know, you can see that's awesome. And then when you combine that, you can see the problem though. When you do that, it starts to intersect a little bit, which might not be an issue, but it also, you know, it sort of takes it off completely off the surface. So it's a little bit, you know, sort of takes away from that being on the surface effect. But I think it's pretty cool. You know, it's cool to play around with this stuff. Just try and get the look that you're after. After the attribute blur, if you wanted it to get back on the surface, you could always do something like this, where you use a ray to ray it back onto the surface. And that's set to project ray, so let's set it to minimum distance. And that will just that will snap it to the closest sort of point that it finds to it. So, you know, we've got these here, and then we're feeding in the remesh, and minimum distance will just snap it to the closest surface on that mesh, and that might give us it back on the surface. There you go. So you can see it just snaps it back out, which is really handy. Rays are awesome. You can also just snap the inside ones, so you could do something like this. Use a group to group those points which are inside the VDB, because the group node can use bounding volumes. You could use a bounding object too. And let's see, it's erroring because it's group type primitives. Change it to points. What you'll see is it groups all the points that are now inside that VDB. We could change it to object to see if that gives us any different result. Maybe just selects a little bit less. There we go. So that's everything that's inside, and then you could just ray the things that are actually inside. Group 1. So that now is just raying the inside ones, not everything. So that could be cool. It just gives you a slightly different Slightly different result. Yeah. Because it then still allows for these ones that are sort of, you know, doing this kind of stuff, lifting off, which is kind of an interesting effect as well. So, you know, you could go and just go crazy with the start point selections. You could also utilize color to do this. So I like to either just use a procedural, let me go and grab this VOP that I had, where was that? Here. Let's try and use this. So we could utilize this to generate some color. We could, let's see, I'm going to put a vec to float, float to vec, I think I want. No, vec to float, float to vec. Oh, float to vec, I think that's what I want. CD, if I plug that into there, I get red. So this could be my like endpoint generation or start point generation. If I crush that right down, so I don't want them, you know, kind of, I don't want it to be crazy everywhere points, because I'll just get way too many lines. But maybe something like that. And then I could create another noise here, different offset, that will change the noise, feed it into the green. So you can see there, there's the offset. So you can see as I shift it, if I do wide or phase the noise sort of vertically, which means it'll change the noise pattern. There we go. Let's create some large offsets. Maybe even just change the frequency. Oh, there we go. Maybe I should do that overall. Just high frequency, give me more little dots. It's probably a little better. There we go. So less ends, more starts, maybe, or you know, crush the red ones down. And then I could do maybe in my shortest path. Let's see if it works. We might have to create a group beforehand. So we'd say at cd.x greater than 0. Well, it's doing something. And then at cd.y greater than 0. And, you know, we don't have to do each start to each end. We could do any start to each end, because maybe that'll just end up with, you know, crazy stuff going everywhere. So, and I might actually just go 0.1, create a little buffer so it doesn't actually create any based on the black values. And I'll do any start to any end. What does that give us? Nothing. Each start to any end. Ah, that's interesting. Each start to any end, or any start to each end. So you can play, yeah, you can play with it. You will also notice there's this cost attribute, and you can use that to control how the curves will travel. So by creating a cost attribute on the mesh, that can manipulate a little bit how the curves travel. Yeah, that one's a bit too heavy, so maybe I'll try creating groups instead. I don't know if that. Let's create a group, point group, at cd. Let's see how many points are actually going into this. At cd.x greater than 0. It's quite a lot of points. Yeah, maybe it's just too many. 2,226. Let's just try and cull that. 683. Maybe I'll just try that. 0.9. 0.9. See how long this takes. I mean, it should be okay. It's just, you know, the more points that you give it, the you know, the longer it's going to take to calculate. Because it's got to go through and create, you know, all those connections for all those points. So if there's 2,000 start points and 2,000 end points, it's going to create just a lot of connections, because it's exponential. It's each start to each end, which means that 2,000 start points, it's going to, for every start point, it's going to connect to one end. So, you know, you're talking, you know, ending up with hundreds of thousands. If you escape it, though, you can see where it kind of got up to. So we can see no, it's not telling me not telling me how many primitives I have there, but you can kind of see what I ended up with. And of course, the density of the remesh, you know, does make a difference to the speed as well. So up the target size, that'll result in a lower res mesh, which, you know, when we're just using this for find shortest path, maybe that's okay. Let's have a look. There we go. Ah, and there we go. So that evaluated a lot faster. Maybe it doesn't look as good, but certainly quick. You can see that the find shortest path is also, because I just generated that noise over everything, it's also wrapping to the underside of the mesh, which maybe isn't, you know, isn't ideal. So there's procedural ways of doing it, but, you know, I kind of like being able to pick it as well. If you're going for a very specific look, maybe it's a good idea to just hand pick it. Doesn't really take that long. Let's try that. Put all the endpoints up the trees and see what that looks like. It means that all the kind of curves will just travel up the trees and terminate there instead of terminating on the ground. There are other ways of doing kind of growth as well. You know, there are procedural sort of systems that you can create that will just move from point to point based on their connectivity, and that can be an interesting thing to try. Pretty sure I've seen some tutorials out there showing that. So what that does. There you go. So you can see, like, there's a start point and it just ends up going to the different trees. And you could always add noise to these afterwards as well to create like a whole bunch of more sort of lines. So, you know, we take that find shortest path, we then put an attribute VOP down to add noise. So turb noise, add to P. There we go, let's make a 3D noise, take the frequency down, so you can kind of jitter everything like that. And then you could always merge those back together. Even just create like a bunch of different ones with different noise values. Different types of noise as well. When you blur those together, because it's based on proximity, it gives you that really interesting sort of knitting together effect. Also, if you have a look at these, because we've now got a sort of lower res remesh, we're getting quite jagged lines. So we could add a resample in there to introduce more points. And that, when we do our attribute blur, will give us a much smoother result. So that's kind of interesting. Now, instead of doing this kind of manually, like where I'm creating multiple noises here and offsetting them, you could potentially do this in a for each loop as well. But I'm just going to do it this way. Maybe I'll do sparse convolution on this one, see what that looks like. Looks like the polywire's having fun. Might be a bit too heavy for the polywire. Let's see. 2 million points. So you could always put a resample down after you've done all that stuff as well. And, oh, there's some interesting things going on there. Put a resample down and then potentially drop the resolution if you wanted to as well. So that, you know, goes from being 2 million points to 500,000. And it's sort of, still looks okay. It's a little bit more jagged, but it's probably going to go through the polywire a little better. There you go. And you get this, you know, interesting sort of root look or growing ivy sort of look, creating that, all that offset. You know, one line becomes an interesting sort of mix of lots of different lines. And that attribute blur really kind of helps with that stuff. So, yeah, I think that's kind of a cool thing to do to create this sort of world, this interesting, you know, dark world. I mean, if we start coloring this stuff, you know, even blue like that, it's kind of cool, but I guess, you know, it probably wouldn't quite be like that, but it's interesting, yeah. We could also, doesn't look like we got any lines growing over these ones, so we could always go back and, you know, pick a, maybe it's the Remash made these a little too coarse, but we could always just go and pick a point on some of these. You know, it's nice and easy just to update, add to. There we go, so we got those ones now. So I think that's pretty cool. I mean, the other cool thing that you can do with this stuff is animate it. So it creates a primitive from each point to each end. And then using a carve node, you can actually animate the ends of, oops, don't want to do it after the polywire. You can trim curves. So you can see I can actually animate this. This is backwards, but if I do it this way, I can actually get animated growth from these lines, because a carve will just animate from one end to the other end of a curve. So I could have this be animated growth if I wanted to, which is cool. And then it really sort of matters where you pick your start points and end points. You can see this one's growing. I have a start point. I must have a start point on this tree. So it's kind of growing on that tree there. But yeah, that's okay. So that's really cool. Yeah, you can animate that stuff, which is awesome. So what else are we going to do? Let's do some, let's just do some variation on this polywire. So polywire will take a width radius attribute. So I can vary, I'm going to just copy this attribute VOP again. Attribute VOPs with noise are very useful for all sorts of things. Except I'm just going to get rid of this float to vec and use one of these noises to create variation. So take frequency down, make it kind of large. Yeah, bit of roughness. You can crush it, don't have to. Instead of putting it out to color, or as well as putting it out to color, I'm going to set a width attribute here. And I'm actually going to not output 0 to 1, I'm going to output, if you have a look at our polywire, we've got wire radius of 0.1, so I'm going to output max 0.1. And you can see that affects my color, but that's okay. Polywire is going to do its thing, and then I'm going to do at width. hey, look at that. So now I've got width variance on my polywire where I've got these kind of really thin bits, I've got these really bulbous bits, which just adds to the kind of cool organic feeling. The thin bits are too small, so I'm going to go and raise my minimum. I'm going to make that 0.05. And then I've got this other noise here. Or maybe 0.02. Just not 0, because that just makes it way too small. 0.02. I could up my Des Max as well, but what I'm going to do is, I've got this other noise, which I was using earlier, and that is giving me this kind of, these random dots. So I'm just going to adjust it to have a few more. Maybe turn the frequency down a little bit. There we go. And then I could use this to create some, like, I'm just going to add a value to this here. So I've already defined my overall sort of random noise for width, but then if I add these random little white patches here, and I'm just going to add 0.05 value to the width. What I'm going to get is these little kind of inflations every so often to create this interesting effect of, let's have a look. I might need to up it. Let's go 0.1. Hopefully I'll see little areas that bloat. I think I noticed it there. Maybe I need to go even further. 0.2. There we go. You can see it there. It's very, it's not really doing it as much as what I would have thought, but there you go. You can see that area there has kind of been inflated. Let's go 0.5, which seems odd because that just seems like too thick, but there we go. It's interesting, kind of just random sort of weird inflation areas. And if we go back to our attribute fob, let's just change this so it's a bit more everywhere. Oh, I was waiting for something that wasn't happening. There we go. So now you can kind of see, you know, just these interesting, weird little kind of things happening. Check it out combined. You can see it a little clearer. So that's kind of cool, you know, some more variation. It's interesting kind of look. What was I going to do? I was going to do something. I can't remember. Oh, that's what I was going to do. So each one of these curves, through a resample, you can do some cool things. You can turn on curve view, which will give you a value from the start, just like how we're using the carve, from the start to the end of the curve. The curve view value will be a 0 to 1 attribute that is on every single curve, which allows you to do interesting things along the length of the curve. But this one is really handy, curve num, which will give you a point attribute called curve num, and it's a different number. It's like a class attribute that we were working with before. It'll give you a different number. Oh, sorry guys, my chat was kind of stuck. I was wondering why there were no comments, and then I realized that that it had been updating and I hadn't been seeing it. Let me just go through all these chats. Someone says, SR Saito says, the most important is to learn the fundamentals and taking a long time, and then in that, after learning softwares. Yes, look, fundamentals, always, very important. In anything, very important. Very boring, but very important. Houdini 19, yeah, I'll get to that. That's a big topic. Thanks, Sebastian. Yeah, freedom in Melbourne. And from next Friday, even more freedom, which is great. It's been a long time in lockdown here. Forums have never been the same, yeah. No, I don't know one Prada. I'll have to look him up. Yeah, I don't use Discord that much, Saito, but yeah. Drawn Skull says, I have a question. What program should I choose if I want to do epic battles, epic gun battles that you would see in the Transformers movies and Star Wars? Houdini. If you want to do any effects, yeah, Houdini is the way to go. Hey, good luck, Focus. Sorry, it was probably a while ago you asked that question, but I'm doing a Stranger Things inspired landscape. Down on the upside down. I was going to say the down under, but that's where I am. Moneyval Rot is the name of the attribute. It's not rotation. You may be able to interchange rotation for that, but Rot is the name of the attribute that you use when you're doing it like this on points. Hey David, how's it going? Wow, really falling back on all these messages. Sorry everybody. Hey GV, how's it going? Wow, GV, I used to work with GV at Method. How are you doing, GV? Are you using Houdini these days? Hey, thanks MDS Anima, thank you for that. Hey Rizwan. Yeah, I was a little bit carried away, David. You're right. I'm sorry, everybody. Hopefully, it'll keep scrolling now. It got just stuck in my OBS window. All right, where was I? Now I've caught up. Hello, everybody. Sorry, I ignored you. So, curve num. If we have a look at the geometry spreadsheet, you can see I've got 4,887 values in here. So that tells me I've got 4,888 because the first one is 0. 4,888 polygons. What that allows me to do is to vary each curve's width, which can be really handy. So it's a point attribute, which is great because we're working on points. I'm going to bind curve num. Make sure I got my spelling right. Curve num. GV, are you still here? Thanks for joining. Hope you're doing well. Curve num. I'm going to pipe this into a random. So this would be the same as doing rand brackets curve num in a attribute wrangle, but I'm doing it inside of here. So this is going to give me a 0 to 1 value, a different value for each curve. And then I can add that or run it through a fit and maybe multiply my overall values that I'm getting by this. So some, let's say, will be half their size and some will be larger than, you know, that'd be 1.5 times their size. Let's see. There we go. So let's have a look with the color. It's kind of hard to tell, but because we have, like, you know, these ones sort of knitted together, hopefully you'll get, you know, some variance on each one of these. It's a little bit hard to tell because we're doing a lot of sort of things to vary. But if I was to just plug that in, let's see what that gives me. Although that's dangerous doing it like that. Let me plug it into a different fit and choose different values. Come on. So I'm going to choose 0 and 0.1. It's updating the poly Y, which is annoying. So let's do this and see if it's working. Doesn't seem to be. Let's just check that I got that right. So I've got curve num, it's an integer. I did not choose integer here. That could be why. Wait for my polywire to cook. No dice. 0, 0.1. Let's change. Oh, actually, let's output the random value into color. Let's see if that makes any difference. Yeah, see how everything's white? That ain't working. Why? Why? Oh, look, we do have a lot of wires here. Many more than what I thought. And yeah, this is the other thing with 4H that you have to be aware of. When you use the each start to any end, is that you potentially actually get a lot of overlapping going on. Because there might be like, you know, let's try and select it. Delete non-selected. There's actually 25 polygons here. So there's, you know, you can see all these fanning out here. So there's actually a lot overlapping here. And that may be kind of why the polywire is, you know, freaking out a little bit. But it does also add to the kind of noise. So when we do the noise, we do actually get a lot of interesting sort of stuff going on. But yeah, it's just something that you need to kind of be careful of, because potentially you're going to end up with a lot of overlapping curves, as you can see here when I do the attribute blur to spread them out. That's the other thing we could do, I guess, is to randomize the noise, and that will actually spread these out even more, which might be cool. But why is our curve num not working? Curve number attribute, curve num. Feeding it in here, running it over points. Curve num, spelled correctly, running into a random. Perhaps it is working, and it's hard to see because they're all overlapping. I don't know. I can definitely see some grayscale values in there. You see that? White, grey. Maybe they're just all kind of blending together because of the size of the polywire, so it just kind of all overlaps a little bit too much. Don't know. Let's add another attribute VOP in and see if that kind of helps. I'm going to do the same thing. Actually, what I'll do is just duplicate this one and steal its components. So I've got my curve num into my random. And what I'm going to do with that instead is I'm going to use a turbulent noise here to add to P, output P. So it's going to noise everything up. Let's make it three-dimensional noise. Let's go sparse convolution, high frequency, low amplitude. Maybe not that. There you go. You can see them all spreading out. But what I'm going to do is into the offset, I'll feed this random, and so it's going to give a different random offset for each curve num. That's kind of cool. It just separates everything a little more. And you can see just how many of those curves I have. Let's up the amplitude a little bit more. There you go. Try the different noises. Alright, now hopefully we'll see some greater variation from this random that we're getting. Yeah, you can see like the thickness of that sort of kills it. But look, there's some really thin ones there and some thick ones, so it is apparently working. It's weird. Yeah, it's weird it's not updating now, but I don't know what's going on there. Width. I don't know. I'm gonna plug it back in there. Hope for the best. That's strange. Oh, you know what? I'm overriding it here, that's why. I'm an idiot. Have to be careful when you, there we go. You have to be careful when you duplicate, you know, VOPs and reuse them for other things. Make sure you're not doing any binds. Alright, there we go. Now we can see we're getting nice variation of thickness. Each one of these curves has a different weight and width. And you can see it's just now very organic looking, which is great. It's a lot of stuff going on there, but you know, whatever. I like it. So, alright, what are we going to do now? We got to get some kind of... Maybe we do this, you know, this particulate kind of stuff. We've got this interesting forest. We need to do a fog and depth. I've got the TV as well. I don't know what the hell I'm going to do with that. Maybe I should just bring that in and put it in somewhere. So let's go and find that. Because it might be cool to actually put it underneath the... it's a Blender file. Yuck. Sorry to all you Blender fans out there, but I do not want it as a Blender file. Oh, that's annoying. I don't think I can load that in. Let's see. I would be surprised if that worked. No dice. Alright, well, guess I won't be doing the TV. Let's do the particles. So all the way back when my messages stopped updating, Moneyval was talking about doing zero-G effect, floating leaves and objects. So, yeah, I mean, you know, I guess the way that I would kind of approach it is, I don't know, I guess I'd just use particles to drive a lot of it. Or not even, you know, it depends kind of what you want to do. I mean, you could just create a large box that encompasses the entire environment. I don't know why I worked so far right of the origin, but if I do this, you know, I basically just created a big box, which within I can do a point replicate. Wowzers, what has happened there? Oh, not point replicate. What am I saying? Points from volume. That would explain everything. Okay, I'm just going to set really large point separation, because what I'm going to do is just, I want to fill this with points basically, but I want to fill it rather sparsely. And I might just take my bottom of my box, you know, maybe I need to kind of make this a little bit better scale. So let's go 20, yeah, there we go, that'll do. And then using my copy to points, I'm just going to copy on something. I'm just going to copy on a grid to start with. A very small grid with no subdivisions. So there you go, I've got some grids copied on, and then I can do the same thing here, attribute randomize, rot, 4-dimensional vector. There you go, got random rotations, -1, +1, -1, +1, oops, -1. Now, this is rotation, right? This is the value of rotation around the random axes that it's generating. So you could animate that value. you could potentially, I mean, you could put $F in here, and that will do some interesting stuff, but it potentially is going to kind of mess with things a little bit. So what you could potentially do is then take that rotational value and add to it. So at rot equals, let's see, what am I going to do? Maybe I can do, plus equals open, and I'm not going to add anything to the axes, but I'll add a at frame to the rotation. I don't know if this will work. Let's see. Doesn't look like it. Oops. It does not like me doing that. I guess I can't do that. Maybe I can do... What could I do? Let's see what happens when I do at frame added to that. Probably not going to like that either. See how it's kind of... Yeah. The problem with this is that it's going to add to the axes as well. So I feel like that's not what I want to do. I can't really remember how to do this now. I'm just going to leave it. So there's our rotation. Let's do a attribute randomize for... I'll come back to the rotation and work it out, but I'll just push on, you know, rather than getting stuck. I'm just going to add some random scales to these things. I'm just using grids to represent leaves, essentially, or, you know, whatever this stuff is meant to be. I'm not necessarily thinking that this is going to be an animated scene as well, so maybe, you know, maybe it doesn't matter that it's kind of completely static like this. Or you could create a static environment and an animated camera that travels through it, which could be interesting. But you can see, you know, they create that feeling of depth. And then you could always replace those with little leaves, or just modify the grid. You know, maybe we go and chuck an edit down and just pull these points around a little bit. Go. Give them a little bit of three-dimensionality, that's not a word, but yeah, you know what I mean. Make them a little bit three-dimensional. And then you'll see now we've got leaves. Doesn't really take that much. So the easiest way to get those to rotate and spin would just be to run this instead through a pop network. So we'll run it through there. We can also give them some noise as well, and some maybe just falling motion. Maybe let's do a pop force. I'm going to do a sine. Do I want to do a sine wave in here? Maybe not. I'll just do a really low gravity and then some amplitude on the noise. And I'm just going to emit all points on the first frames, $F less than 2. Turn off the guide. There we go. Turn on real time. Okay, so that's a bit too quick. Let's go 0.1. That noise is too strong. And let's do a spin. So you can define axes here, and you can also do like some random stuff or rotation stuff through Vex here. But let's see what that gives me. I'm just going to do P-scale. I always seem to forget how to do this rotation stuff with particles. Oh, you know what? They're probably rotating around just the y-axis. Maybe. I guess... actually, they should be changing based on the speed that they're traveling. Oh, there we go. Now they're spinning. Look at that. So the speed, maybe. Spin speed. I don't know. As many people have asked, or I've seen, you know, people ask various questions, you know, about how you remember how to do everything in Houdini. Sometimes you just don't, and you forget, and then you have to go and look it up again. But that's kind of okay. And we could always just add the rot on there as well. You'll see what we get coming out of here is an orient. So, you know, if we add the rotational value on top of that, we are going to get just random rotations as well as that updating orient value. So you can see, well, it's very subtle, but you can see they're rotating as well as, you know, now having also random orientation or random rotation as well as that updating orient value. I don't know. It's probably okay. So, you know, now they're falling, but we could have them rising instead, or just not doing anything and just have noise kind of on there, so they're slowly swirling around, you know, very subtly moving, super subtle. It's got a pretty high frequency noise on it as well. If you have a look at the guide, you can see, well, it's a bit hard with the amplitudes, although you can see it's quite high frequency. So if you take the swirl size up, they'll swirl around, you know, a lot in a lot larger swirls. You see them move a little more now. So you could have a few different variations of this effect to create, you know, just variants. PopNet. So I'm going to make this a still. So I'm just going to freeze this at a particular frame. Let's just freeze it at 100. Oops, not that. At 100. And then I'm going to duplicate my points from volume and my PopNet. And I'm going to add many more points. Run my PopNet again. I'm just going to change the offset of my noise so that I know that I'm going to get a different noise. Maybe even change the swirl size a little bit. When you're duplicating setups like this, it's always good to just vary the settings a little bit so that you don't get things moving in exactly the same way. And then now I've got that, I can do the same thing. I might just use P-scale because I might just use this as a kind of fine particulate, you know, rather than being large stuff. It can be hard to see sometimes because the points display so brightly, but you know, this one could just be little spheres or little planes. Whoa, too much. Something like that. Yeah, just really, really fine stuff. And then, you know, what have I got? I've got half an hour left. I could do quite a bit in that time, but if I duplicate this box here, so it's kind of filling my environment. I could just do a B2B from polygons on that to create a fog. Make it a density. Put a volume wrangle down. say at density times equals 0.1. Let's show objects. Let's see. There we go. Oh, we can see it there. So there we go. There's a little bit of fog happening. You could also just do that with a volume visualization rather than changing the actual density value. You could just do it with the visualization, which then you also have to go and do in the shader. There you go. So you could do, you could do that sort of thing to add depth. You could also use a volume node set to from camera and point that to our camera. Create density, give it an initial value of 1, and then this allows you to set it based on the camera near and far settings. So we could let's see, have a look through the view. Oh, there we go. So you can see, if I crank that up, there we go. So you can actually just add fog, particularly where you want it, based on the near and far settings. So pull this back a bit. So something like that might be interesting. You can do by size, whatever you want. That will create a Houdini volume, which you could then convert, if you wanted it to be slightly more efficient, to a VDB. Now it's a VDB, still density, still the same, but just maybe slightly more efficient. So you could do that sort of thing as well. And then if you wanted to create kind of depth to that, like a fall off from one area to the other, what could we do? Let's use this. Do I use that one or this one? What I might do is just make this 10 to 150. That's all right. 9 million voxels. Now I'm going to put a volume VOP down. And I'm going to use relative to bounding box. So rel b box. Plug in P, so P is the reference. Even though we're dealing with volumes, we still have P position for the reference of each voxel position. If I now, this outputs a vector, so it outputs the bounding box values relative to the side, so they're actually just 0 to 1. So whatever the bounding box is, doesn't matter, it'll still output me 0 to 1 values, but it'll give me a 0 from one end and a 1 to the other end. I'm going to do a vector to float so I can access the various components. So we've got X, Y, and Z. So this is X, this is Y is up, and this is Z. So let's do Z. It's this one. I'm going to multiply the Z bounding box by the density value. And there we go. I think maybe I saw something happen there. There we go. See that fall off that's happening there? Right at the end? If I put that through a ramp, call it a spline ramp, you see it'll disappear because the spline ramp value is 0. But what I can do is actually control the fall off of my fog now from one end to the other. So I can have the fog right at the start be very subtle. This looks like this is the start here, so you can see how as I take that up it falls off. So I can have the fog start there, and then sort of as it goes further back it falls off. And if I make this not linear, maybe I make it a B-spline, I can get a bit smoother interpolation there. When I look through the camera, I should be able to see that a little bit clearer. So that can be a really cool way of, doing the fall off, because it's based on, the bounding box of the object. And this is useful not only for stuff that's from camera, but just where you want to fade things off on one side or the other. It can be really, really handy. I'm going to take the div size up. It doesn't need to be that high res. This fog volume. And yeah, we can still vary the density after the fact if we wanted to. We could even make it black fog. Let's see if that works. There we go, look at that, into the darkness. So, you know, there's lots of kind of potential with that to create some interesting fall off. Of course, you know, you could almost do this sort of stuff in comp as well using a Z depth, but sometimes it's useful to have it in 3D. Let's go and see if we can render something out. You know, I should save this before it crashes and I'll lose everything. Stranger Things environment. How's everybody doing out there? Anybody from Melbourne? How's freedom treating you? Environment. Okay, so let's go into this section and create some nulls, because I don't want to render everything together. I'm going to take my null out trees. Out, I don't know what to call that, wires. Out leaves. Out particles. Okay, so we're not going to render anything from this node. We're just going to merge things out. So this will be env object merge. And what am I going to do? Assets. Okay, out trees. So that's my environment. Duplicate that. This one can be wires. Another process I could do to these wires is also to turn them back into, or turn them into a VDB, convert it all to a mesh, and then, you know, 0.1's probably a little high, and then do some mesh processing on it, like some VDB stuff on it, which might be interesting. So, yeah, that could be a cool thing to do. You could also actually do this potentially, instead of using polywire to generate those curves, you could do VDB from particles, because you've got a whole bunch of points here. If you did a VDB from particles, that could be interesting. Set that radius scale to be, I don't know if I can do that, at width. Let's see if that works. No, it doesn't like that. But what I could do is, I've set that width attribute. Let's just go at p scale equals at width. Yeah. Get rid of that. Set the point radius scale to 1. Now, that width attribute that we're using for the polywire, I've converted it to p scale, and that's going to now drive the size of these little blobs of volume. And then if I do a convert VDB to polygons, it converts it to polygons. You can see we probably do need more points, so in our resample, you can always add another one. That will add more points along the length of the curve, and that will generate more blobs of volume, in turn generating a higher density mesh. So that can be kind of interesting, you know, it gives you a bit of a smoother result. You can add a little ISO value to pump those up a little bit. There we go. So, you know, it gives you this interesting homogeneous kind of mesh, whereas the poly wire will give you a very, you know, separate, but this kind of all blends together, which is quite interesting. So maybe I'll use that in my outwires. Okay, so that's enough of that. And then we're just gonna duplicate. This one's gonna be leaves. Now leaves. And I'm just gonna hide the assets. Hide all that stuff. Whoa. Particles. Okay. What have I got here? Oh, this is my volume. So call that one volume. Alright, so let's create some materials. Principled shader. This one can be our kind of environment. I'm just going to go for a dark color. Turn off use point color, so I'll just overwrite that. Turn off the reflectivity for now. I'll just call this env. I'm going to create another principled shader for the wires. I mean, they could be black as well. Might be interesting to have them glowing. I don't know. Could leave them as the weird blue color, and then use emission. You know, might be interesting. I don't know. Let's try that. Wires. /mat /wires. /mat/env. We just want to make sure that we don't have a shot material path on here, because that could interfere with, there we go, there is one. Probably the one I assigned to those sticks. I'm just going to attribute delete that, so I'm just going to do a brute force material over everything effect to start with. And what should we do? Let's put in a little environment light in. I'm just going to use one of the crappy built-in ones, but I'm just going to have it be very low. Okay, let's render. Check my alpha. Okay, so my trees are there. They're not really getting much. Let's crank this light intensity a little. Check this. Oh, you know what? I have this color correction on. Let me turn that off. Oh, there we go. So they're there, but they're not really getting much lighting information. And this blue is just intense. It's not actually illuminating the environment either. So we could add reflection, and that will kind of give the feeling of them being illuminated a little more. Yeah, see that? Now I might turn down my environment light again. So now I've got no light really. I mean, there's a little bit of environment light, but I'm getting the reflection from my super emissive kind of glowy stuff. I don't know, maybe it's a little bit too intense. It's kind of ruining the vibe a little bit. So I might ditch that for something else. Let's actually go, let's just duplicate that. Let's go for like a kind of weird go for a weird vibe. If in doubt. What do I want to do? I'm going to add... I'm actually going to use the classic shader. I find it a little bit easier to dial in wires SSS. So I'm going to try and get an SSS feeling going on, and I find the classic shader is a little bit easier to do that with for some reason. Might just be personal preference or, you know, my experience, but turn off reflections, add subsurface, set to single scattering. Yeah, I mean, you can do a lot of this with the principled shader as well, but yeah, just, I don't know. Subsurface color, let's set that to red. Oh, that's weird. Okay, and we don't really have any lights in here that are going to give us that scattering. So, and the environment lights certainly, I don't think will help, you know, cranking that up. It's not really going to give us that scattering that we want. Oh, that color is coming from the point color. Let's put a white on there. Okay, there we go. Oh, there we go. We're getting some scattering going on. But it's also illuminating everything. So one thing that you can do is have multiple lights for different objects. You know, we could either have two environment lights, one doing the trees and one doing the weird, you know, whatever they are, wires. Or you could also put in like I like to put in spotlights for SSS. So let's just go and put a spotlight in. And then I'm going to use the light linker. New pane tab type, mantra rendering light linker. Choose the spotlight and untick everything but the wires. Go back to my render view. Render. And now it's probably going to be a bit bright, this spotlight, but it will be affecting only the wires, not the environment. There we go. So you can see the environment hasn't changed, but I'm getting now this interesting bright scatter coming through on my wires. Still getting shadowed by the trees, but anywhere where that light's hitting is going to get interesting, intense scattering. Let's turn this down. Yeah, so you can see, you know, and especially when I take the environment light down, then it kind of creates a weird sort of fleshy, you know, kind of stuff. It just feels a bit odd, which is cool. A bit strange, you might say. So what else could we do? Let's go and let's play with the material. Classic shader. We can give this reflection as well. I just turned it off while I was focusing on the SSS so that, you know, it's a bit shiny as well. Take the roughness down, even add a coat reflection, get it looking really kind of glossy. Coat will just give it that extra specularity that's quite interesting. Shadow is pretty harsh. We could change that spotlight to an area light. It will introduce more noise, but it might just stop these really hard shadows. So let's make that a disc light. You can still have the spotlight option, but it will feather. See how that just feathered that edge a little bit? You can also turn off the spotlight completely, and then you've got area light options. You could just make those. See how when you go larger on the area light size, it increases the size of that light, and it will just blur the shadow edges. And that can, you know, that can sometimes help. Just sort of blur that stuff a little bit more. Alright, that's interesting. Let's go back to the SSS tab. Low scatter distance will result in much less scattering, so, you know, take that down if you don't want tons of scattering, maybe you just want a little bit. Or if you want a lot, put it up. And you'll get a really sort of transparent look, which can be quite interesting. You see this kind of green color? What happens with the scattering is that it's to do with the phase, and it will actually eventually go to the opposite color of the color spectrum there. So you can see these blue tones coming in. And it kind of inverts the color. You end up getting, it's what gives you that interesting look, but it ends up kind of flipping the color, and you end up with the complete opposite color, which can be annoying sometimes, but in this instance it kind of looks cool and weird. So maybe I'll leave it. Let's create I'm just going to create my own because I find it the easiest way to create a super simple volume shader. I'm just going to use a volume shader core into a compute lighting node. Layer, CF, OF, whoops, and F. And then I'm just, I'm just going to bind density. So we only have a density field, so we just bind density, plug it into density, and then we can control the density scale here. So let's, I'll set it to 1, set the smoke color to black, and then I'll call this fog. /matte/fog. You can see that when I do that light linker stuff, this is what it's actually doing. It's adding an exception here to every other object except spotlight, but on the wires you'll notice that that one isn't there. Let's turn the volume on. Now if I look at the alpha, you can see that fogging out the background, and you can start to see that creeping in to this environment. Play with the density scale. The fog arguably doesn't need any lights as well, so what I might do is exclude lights from that entirely. You can see it renders a lot faster. Oh, my camera froze. Thank you. Let's see. Womp womp. Can you guys hear me? Could you hear me just then? I think maybe you couldn't. Yeah, okay. Great. I was talking away like an idiot, and so it seems like when I turn off my camera, my microphone also goes off, which is not great. I'll just have to live with my frozen head. So I mean, you could see what I was doing, but basically, I was just saying that you know, if you turn off the environment light, you still have this interesting spotlight effect um, coming through. So, you know, it still looks cool. The environment isn't being lit, but it is reflecting the wires, which is kind of interesting. We're not really seeing the leaves because they are not being lit by the spotlight. But what we could do maybe is, let's turn the environment light back on, and I'll exclude, just gonna hit stop on that. I'll exclude the environment from that calculation. So, oh, that's shadow mask. Oops. Light mask. There we go. So I'll exclude the environment, all that stuff, and then the environment light is just going to be lighting leaves and particles. So let's try that. While that's rendering, I'm going to see if I can fix my camera. Hey, okay, look at that. I got it back. Alright, so yeah, there you go. You can see the leaves and you can see the particles now illuminated by the environment light. So yeah, I think that's an interesting kind of combination. You can just mess with that value. You could also probably take out add the spotlight into the mix for those, because then you'll get some interesting highlighting from the spotlight potentially. Yeah, I don't know. Perhaps it's good to have the environment light in there. It's kind of hard to tell. Let's go back to our fog. Turn that down a little bit. I mean, I had a quick look at reference before I did this, but I'm not really slavishly trying to copy anything. I'm just trying to make something interesting. You could also not have this be completely black as well. I mean, that, then will kind of create, oh, I guess because there's no light, there's actually no light on this fog, so it is going to display black because it's kind of in shadow. What you could try is upping the emission. Let's see what that does. There we go. So adding emission to it is going to turn it into that grey kind of fog. And that gives a different kind of look again. So yeah, that could be interesting to mess with. If you wanted to add a little bit of tone to that, so it's not completely black. Yeah, I don't know. Just messing around. So hopefully it was interesting anyway, and you saw some interesting techniques. I definitely think this technique for the find shortest path is very cool and very useful. Lots of cool, kind of procedural and weird organic meshes that you can kind of create, even if you're not doing animation with it or ivy or any of that kind of stuff. Just, you know, interesting sort of roots creeping over things, or just weird organic slimy looking stuff, I think you know, is quite cool. Yeah, cool. Oh, thanks. Sorry about my camera and my audio dropping out for a little bit, but hopefully it's all okay now. Before I go, I wanted to mention that there is a VFX Open Day coming up. You will see it in the link down below in the description. But let me open it up. 1 second. CG Spectrum. Let me open my Slack. I will find the link, but it is in the description if you want to check it out. We've got an open day coming up, so basically you just register and you can come along and find out what we're all about. If you want to come and chat to us, there's a few of us talking. Myself, you can see that, Ben Fox, another one of our mentors of Houdini effects, and also compositing. So it'll be both Houdini and Nuke compositing that we're mainly talking about. And there's also the opportunity to get a real review, so it's limited, so you need to register, and then I think it's here, webinars@cgspectrum.com is the link. So if you want a chance to be picked for this real review, then send your reel through and we'll do it on the open day, which will be a lot of fun and potentially very beneficial for you if you're looking to get into a career in VFX. So if you're interested, join the 236 people that have already signed up, and yeah, come on down. It'd be great, you know, great to meet you and tell you all about what we do here at CG Spectrum. So yeah, links in the description, and webinars@cgspectrum.com if you want that real review, which I think would be really cool. Yeah, all right, my time is up. It's time to put this one to bed. I think it's fun. It looks pretty cool. I'm pretty happy with that result. Looks kind of creepy and weird. You can imagine some kind of creature creeping around there. It would have been nice to have a weird TV sitting on the ground, but maybe next time. Thanks, Alan. Have a good week, everybody, as Alan says. Thanks for joining me. Check out the previous Stranger Things streams that I've done as well if you're interested in this sort of stuff. There's some other interesting techniques shown there. But I'll see you guys next week. Have a good week, everybody. Bye.